Okay, so in this video we're going to be talking about the day 4 warm-up, and in this case we have some questions that you have to answer in writing. Okay, so the first question says, explain what is meant by absolute zero. As always, try to answer the question on your own first, using what you learned in yesterday's notes. Okay, so hopefully in the notes you learned that absolute zero, aka 0 Kelvin, is basically the lowest possible temperature you can have. It is by definition impossible to have a temperature lower than absolute zero, and the reason for that is because at absolute zero, all atomic motion stops. Okay, so that is what is meant by absolute zero. It is the 0 Kelvin temperature at which all the motion of the atoms or molecules making up an object would stop moving. And now I'm not going to write that out for you, but hopefully that's basically what you said when you answered this question. Okay, now question 2 says, as a balloon is heated, the balloon expands and does 35 joules of work in the process. Okay, so like normal, you need to make sure that you identify your givens as you go through. Assuming the balloon is heated with 120 joules of heat, okay, calculate the amount of heat absorbed by the gas or absorbed by the air inside the balloon. So remember, the symbol for heat is Q, and so this is going to be the first law of thermodynamics, which says that the heat that goes into an object or that goes into a system, either some of the energy goes to work or goes to delta U, what we call the internal energy of the system. In other words, it is absorbed by whatever makes up the system. And so in this case, we have our Q is 120. We have the work, which is 35. And we're basically solving for delta U. Okay, so because we're adding 35, we want to subtract 35 on both sides. Okay, and so delta U is going to be 120 minus 35, and that's going to be 85 joules. Okay, so hopefully that was a pretty basic calculation question. Pause it there if you need to take a look at that. Okay, so I'm going to erase this answer. Question 3 says a machine is created that claims to be able to output 1500 joules of energy for every 1000 joules of energy that goes into the machine. So this is obviously the output, and it says that this is the amount of energy that goes into the machine, 1000 joules. Okay, so this would be the input. Okay, so the first thing we're going to do is calculate the efficiency, which is output over input. Okay, times 100. So the output is 1500 joules. I had some people ask me, how do you know which one is the output and how do you know which one is the input? Usually you can tell based off of context clues. In this case, it actually says output, so that's a that's a pretty big hint. Okay, so 1500 divided by 1000 times 100 should give you 150%. Okay, now right away this should be a red flag because you cannot have more than 100% efficiency. Now, what law does that involve? Well, you might say it's the second law, because you might remember the second law having something to do with the efficiency. This is actually the first law. The reason it's the first law is because, so according to the first law is basically conservation of energy. Okay, energy cannot be created or destroyed, but it can change forms. Now, if you put more energy out than you, if you get more energy out than you put in, that basically means you are creating energy. Okay, well, that's not possible. That violates conservation of energy. And so that violates the first law of thermodynamics. So this is obviously like a scam machine. This guy's trying to scam you, whoever's trying to sell you this machine. So basically, according to the first law, you cannot have, okay, so the efficiency cannot be greater than 100%. Okay, that's physically impossible. Now, according to the second law, okay, the efficiency has to be less than 100%. Okay, so the first law says you cannot get more energy out than you put in. it says you cannot have more than 100% efficiency. The second law says, wait a minute, you can't even get to 100% efficiency because there's always going to be some type of friction that removes energy from the system. Okay, so that's how you would answer 3B. Pause it there if you need to look at that some more. Okay, and then question 4 says, state 2 examples of situations where entropy of a system increases. Use real-life examples. Okay, so here's 2 examples. First of all, if you have ever added, like, so I drink bottled water, and I add like flavor mix to my water, like cherry or strawberry or whatever. I just put a couple squirts in the water bottle and I shake it up. Now, when you put the flavor into the water, if you just let it sit there, eventually, over time, what's going to happen is the flavor is going to mix with the water. Okay, so right when you pour it in, the water is separated from the flavor. The flavor is at the top and the water is in the bottom. Okay, when you shake it up and you mix all of that together, that's an example of increasing entropy because you've basically increased the disorder of the system. You've made it less orderly than it was before. Okay, now let's see, what is another example of increasing entropy? Okay, well, another example of increasing entropy would be basically to take a balloon and heat up the balloon. Now you might say, why would that increase entropy if you just heat up a balloon? Well, if you heat up a balloon, what's going to happen is the air inside the balloon is going to start to move faster. And if it's moving faster, just imagine those atoms moving around, flying around faster, colliding, more often. Okay, the pressure is going to increase. Okay, and what's going to happen is the system is going to become less ordered because now those atoms are going to be moving faster and everything is just kind of more chaotic inside the balloon. Okay, if you think about the atoms inside the balloon. Okay, so those are 2 examples of increasing entropy. I gave lots of examples in the notes and in the videos. Okay, so hopefully you came up with 2 good examples of your own. Please let me know if you have any questions. And as always, I will see you guys in the next video.